So, next presentation, it comes from Mr. Joy Apa, Director of Business Development at Rivada. Mr. Apa, the stage is yours. Thank you.
Hello, good afternoon. Thank you for coming after lunch. It's always the challenge, but you made it. Thank you for all the associations, but in particular, the big thank you I want to give is to Adonis Violaris for putting all of this on. It's not easy, especially on a Friday, especially in the afternoon. So credit to you and to your team. It's wonderful. I'm going to start by disagreeing with David. I don't think the Leo will be the alternative prime. I think they will be the main prime moving forward in the future. I think the cost will come down. You did mention on the per meg it will come down. I do fully expect that we're going to see a radical change in pricing moving forward. Quite what that means in terms of packages, we'll wait and see. But all the research from recent organizations like Euroconsult and NSR have stated quite a decline in the pricing on the per meg moving forward. And in part, that has a lot to do with the vast amount of additional bandwidth that you are going to see flood into this market in the next few years to come. I'm going to be a bit provocative, if I may, because it's Friday afternoon and hopefully no one's recording this. What you see on land today, you will have as a minimum in the next few years to come. And the potential for maritime is a better experience. Now, there are some integrators in the room that will probably stare at me and say, how dare you, do not make a commitment on my behalf. I'm not making that commitment on your behalf. I'm just stating what I see to be true based on technology. And now I'm going to take you through Rivada Space Networks and tell you what we're up to and why the likes of ourselves and the other LEOs, the Starlinks and the Amazons, will create that additional capacity, why we're going to do it better, and why that means you're going to get the performance I'm mentioning. So let me, and David, thank you for the mention. I do appreciate you mentioning Rivada Space Networks. I brought the wrong glasses, so I've got some notes that I'm going to look to. Who is Rivada? I fully expect that nobody has ever heard of Rivada Space Networks. I'm not going to offer you a free iPad if you have, that's too generous, but put your hand up if you have heard of Rivada Space Networks. Yay. Thank you very much for paying attention. We are one of the new players. We were formed as Rivada Space Networks this year. In March 2022, we're a subsidiary of Rivada Networks, which is a US-based company. They were formed in 2004, so we do have backing from our subsidiary. We are focused in the US on design, implementation, and operation of wireless interoperable networks, specifically into the public safety community. So we've got background in communications, we've got backing and funding from one of our main investors, who was a chap called Peter Thiel, who was one of the original co-founders of PayPal and one of the first outside investors of Facebook. So we do have good support. We do have offices based in Germany. The main office is in Berlin. We have another office in Munich. Berlin typically is where most of our engineering resource sits. We are looking to spend approximately 4 billion euros to launch our LEO network. What does that look like? This to us represents two main launches. One will be the first 300 satellites. So we'll be doing it in two phases, 2 lots of 300. The first 300 will give us true global capacity. Why launch another 300? That's going to give us additional extra capacity onto the network. So the first we're estimating, because we're still in the design phase, which we hope to conclude this year, will be in the order of multiple terabits. We think around 6 to 8. And then the second will give us that additional capacity again. We're going to be doing things a little bit differently. We're going to be operating in the Ka band spectrum. That has certain advantages on spectrum availability. The model we're going to adopt is B2B. So we're going to be selling to integrators, stroke resellers. So through a partner network. We're not looking at this from a consumer standpoint. This will be treated very professionally within the maritime space, dealing with our core partners that hopefully some of you deal with today. You will need an integrator for sure. You will need that person to support you for sure. We're going to be focused on the satellites and ensuring we deliver the service and the capacity. B2G is an obvious area just because of the government requirement in what they need and the bandwidths they also need to supplement their own government satellites. We are looking at our first launch in 2025. That might seem a way away, but gosh, the way time flies these days, that will be on us very soon. We're looking at our full constellation really being in place by 2026. And that's when we'll look at our first start date for service. We're focused on high data throughput. I'll get into that on the next slide. We're focused on point-to-point connectivity. There will not be a gap in the world where we can't deliver service to. So our network of 300 will cover the globe completely with no holes in it. We're looking at ultra-low latency. We predict we'll be the lowest latency provider on our network because of something that what we're doing in space, which is using laser technology. David mentioned that earlier about how some of the providers, certainly during Gen 2, will switch to inter-laser or optical inter-laser satellite connectivity. We're going to be doing that on day one. The benefit of laser when you're in a space environment within a vacuum is it operates exceedingly quickly. Just a little bit more about the space segment side of our network. So I mentioned 300 for the first phase. We'll carry spares. We'll have 24 orbital planes going from pole to pole. Each orbital plane will have 25 satellites operating within the plane. The clever thinking about this network is we're not going to be using any ground station infrastructure whatsoever. No ground earth stations, which is radically different from the traditional setup for any satellite provider today. And that is the crux of their issue. If they have to go up to space in order to come back down to deliver that connectivity across the local infrastructure or fiber or break it out into the internet, it slows things down. It becomes a security risk. If you keep it in the space and you keep it over laser and you drop it down to your endpoint, you are now faster than fiber on the ground. So one of the business areas that we're looking also into, in addition to maritime, is also questioning and rethinking the entire model of why anybody uses today fiber connectivity on the ground. So the future of laser and the future of LEO combined means arguably that we change the entire way we do communications in the world today. This isn't reserved for maritime. This will be a global, radical rethinking of everybody and how everybody does communication in the world today. Think about it. If you're here today trying to do connectivity from your office, you generally are using the internet, or if your data is that important, you're putting it over a fiber link, or an MPLS link, or a combination of the two, or many. And the risk to that is security, and the risk is that connection sometimes fails. How many times has a lease line been compromised? It happens quite a lot. And backup systems are used. Why use that at all when the future says your connectivity is now in space via laser connectivity? Bring me back in 3 years. We'll challenge all of this. How are we going to do it? Well, David touched on it. Smaller modular hardware on the ground will be used. Maritime at sea, we fully expect that's going to be in the form of different forms that gives you a different QoS. So think about it simply. You might have a larger antenna that gives you the capability to do more bandwidth versus a smaller antenna where that bandwidth is going to be slightly lower. Good God, I've got to go back one. There was one important thing on here I wanted to mention and draw your attention to, because someone is going to ask about what the speed is that we're looking to utilize. The up and down link will be a minimum of 100 megabits per second, reaching up within the beam to 15 gigabytes per second. So that is a massive increase on anything that can be experienced today. That's within the beam, and there will be many beams, several beams under the satellite that effectively will operate in a beam hopping fashion. So this is super clever. This is me trying to be technical. I don't want to get into the technicality of it all, but if you can imagine, you know, where a user needs to light up, then a beam is attracted to that user, to that vessel, and that connectivity is allowed to happen. If he switches off and doesn't need it, the beam can change focus to other users. The other key thing about this network, I'm going to refer to David again. He mentioned Starlink, and you mentioned how the user experience and the user community is settling on this, what is their throughput. The reason is because it's contended. The more and more users they currently have on a network, the lower the speed. It's a simple physical thing there. What we are doing is first and foremost promoting CIR only. So that means it's guaranteed. So we will guarantee the bandwidth, we will guarantee that throughput, and we will offer as a side benefit, if contention is a requirement, that's something we can later build into our pricing model. But this first and foremost is B2B, and it's CIR only. Now I can go back. Can you see that? Or is it my eyesight? Okay. So this is going to be a business grade carrier Ethernet type solution. If you, again, think of this as no gateways, everything's done in space, all the connectivity is done on the satellite. Each satellite will have several laser diodes that talk to each other. The final design phase to be concluded, but I'm guessing it's going to at least be up to 4 laser diodes per satellite. Don't quote me on that, but that's my belief at this moment. So each satellite can talk to its neighboring satellites. What that allows you to do is not only go from a point-to-point fashion in the carrier world, as we talk about it, which is called E-line, going point to point. You can do something called E-LAN, which is multiple to multiple. So you may have many vessels talking to each other, or many offices enabling you to go from any to any networks, or something called E-tree. Think of it like your tree with roots being able to then communicate data and send to many branches at the same time. So that's more of a a broadcast fashion of approach. So again, this is another radical game changer with the networks of the future. It's not just simply reserved from a point-to-point, simple up and down connectivity. It'll be many-to-many or one point-to-many. So that'll enable corporate networking. It'll enable the unheard of thing where you could have a fleet of 200 vessels all being able to send out messages from one vessel to many or many to many at the same time. Won't dwell too long on this one, but it's just a simple, this is the state of technology today. You will either be looking at coverage in a geo fashion, which doesn't give you full global coverage. The poles are typically not reachable because the satellites sit over the equator. Or you look at MEOs that are being proposed, they're not high enough, so the bulk of their connectivity is just up and down from the equator up to about 50 degrees latitude. Or even today, when you talk about LEOs and what is being put up by OneWeb and what is being put up by Starlink, I'll refer to David again. You better buy me a beer. There is no global coverage. That map showed you. It's, on the one hand, it's reliant on where you build the gateway. These are networks that require gateways today. That might change moving forward in the future, but right now, today, your connectivity and why you can't get global coverage is because of your limitation of gateways. Now, for Rivada, because we're not building gateways, that gives us an incredible advantage. It means once the satellites are in space, we have instant global coverage from day one. It means we don't have to spend money building out gateways on the ground, and it means you don't get tied into long-term regulatory licensing approvals for countries to enable you in order to go there to build the gateway on the ground. Now, we still may have other issues with other countries, but it won't be because of gateways. It's that time in the afternoon where I'm not going to test you too much, but I'll give you a couple of simple things I'll pick out from this slide. It's 30% faster to operate in a vacuum in space than fiber optics on the ground. Okay, so just think about that. That goes back to my, why would you use fiber connectivity on the ground today when you can do it in space? The return time, typically in latency, on average, I suspect is going to be less than 100 milliseconds. Less than 100 milliseconds. That is an eighth of the time that a GEO will do it today. Probably actually greater than that, because a GEO today still has to connect from the end gateway point to the end destination of where the traffic needs to go. So a lot of GEOs, we talk about latency being about 800 milliseconds to 1,000. So this is going to be significantly quicker. I've put up one example there just to show the worst case scenario. If you go from one point of the world to the other, Madrid to Wellington in this case, two of the furthest points apart on the globe, our calculations are that will be less than 260 milliseconds. Significantly faster than fiber and significantly quicker than what we have today in the satellite world. Now, here is it's kind of like a slide that really talks about what we see today. There's a Type 1 network that we have with OneWeb, Amazon are proposing, and SpaceX today, where they have to use what is known as a bent pipe technology. So it goes from the vessel up to the satellite down to a gateway. Type 2, that some of the players are moving into, if you can pick out where it's gray. So Amazon SpaceX and OneWeb are talking about introducing laser onto the satellite. So you might pick that up in the press today. A lot of that isn't in play today, but it's potentially where they're going to go tomorrow. So to try and do them a little bit of justice, this isn't how do I beat up the competition, this is how we see the landscape today. When they move into that environment, we call it a type 2. That's where still at that last mile, there will be a gateway and then the final delivery to the customer. Or then compared against that, because Rivada isn't within a type 1 or a type 2, we created a type 3. And that is where it goes from point to point. There is no gateway, there is no delay, there is no land infrastructure that's needed or utilized. And if you're still awake, I am going to tell you why the award, somebody's smiling, thank you. Spectrum, frequency allocation. In order to put satellites into space, there is a process. You have to at least apply for the spectrum. In the US, the common body, the regulator is the FCC. Most people have heard of them. What we have done is had our spectrum allocation approved by Liechtenstein. It's normally done on a first case, first base service or a principle. We applied for our frequency spectrum back in 2014, and we had it approved last year. Or was it the beginning of this year? It took a long time. It took about 7 years for that approval process to take place. Now, that's not to say that happens all the time, every time. It just takes a bit of time. There were 3 companies ahead of us that had their approval. 2 of them have joined forces together. That is Thales and Telesat. The other is OneWeb, but OneWeb today is using Ku band for their satellite connectivity. So that's slightly different. And squeezed in the middle, I should say rather, Rivada has 2 filings. The first filing, 3ECOM1, was for the first 300 satellites that I mentioned. The second filing, 3ECOM3, is for the second 300. Squeezed in the middle came along SpaceX. Now, why that's important is you generally in this world have to be a good neighbor. If you're running a fleet of satellites, you have to make sure your satellites aren't the problem, aren't interfering with your neighbor's satellites, aren't doing things they shouldn't be doing, too much power or frequency interference. If that's in question at all, then you have to go and discuss that and reach agreement with the person that filed before you effectively to ensure that there's a solution. So in this case, for everything that happens outside of the US, SpaceX will have to coordinate with Rivada Space Networks to ensure that, again, they're being a good neighbor. Nothing erroneous about that, but it's just the way that the system is set up. But if anything, again, it's just a bit of comfort to try and demonstrate that Rivada Space Networks is serious about what it's doing, is a player in this space, and has quite significant priority over a myriad of other organizations that have also applied for spectrum within the Ka band. That's not to say that all of a sudden you're going to see over 100 other satellite networks. Most of these probably won't come to fruition, and some of these will be for completely other different types of services that won't be reserved for communications. That's the schedule that we are working towards. I'll give you a second to absorb that, but effectively, if you look at where we have 300 satellites there on the banner, you'll see we're looking at really around mid-2024 to start to launch. Most of the satellites will then be operational by 2025, and we'll conclude the first 300 by mid-2026. So by end of 2024, we're going to start testing. We'll probably have some early bird satellites that we'll look to test with customers on, just for proof of concept and performance and QoS and the usual. Most of then the world will start to be covered from the pole moving down towards the equator as more and more satellites are being launched. So 2025 we'll be operating service within regions. I fully expect that's going to be covering the Mediterranean and above. And then by, again, 2026 is where we have our conclusion for full global coverage. What are the benefits? Hopefully some of them are apparent. Hopefully some I've already mentioned. Security will be one of the key ones, because again, we're not looking to touch the ground infrastructure. You will find laser connectivity is incredibly secure. So that's certainly something that will be of major benefit. Ubiquity, any customer anywhere. Once the network is complete, we're not again rolling out through gateway. It will be a globally available network for any customer anywhere. Resiliency, if there is an issue with a satellite, because they can all talk to each other and they have the ability via laser to connect around a defunct satellite whilst the spare is moved in to cover that satellite, continuity of service will continue. Capacity, it's going to add quite a large number of terabytes of additional capacity within the network. We estimate that's going to be in the magnitude of about 8 terabytes of additional capacity. So to try and put that into context, I mean, that's multiple times what we are currently seeing within the community of satellite communications today. Latency, it's going to be faster than fiber. We'll forget about, is it going to be faster than today's VSAT, today's KU, or today's L-band? It's faster than what you subscribe to today on the ground. Scalability, cost-effective redeployment. Again, we're not building out through a gateway. It's easy for us to do that global connectivity, rapid deployment. Once the network's in place, again, all it takes is a user terminal and or connectivity to a corporate POP, an integrator's POP, and then the traffic being layered with the value adds of that reseller today that serves its customer in the same fashion, if not better, than they have already in place today. The interesting thing that we're waiting to see will be what developments happen in this space of maritime. If you provide more bandwidth and if you provide that low latency, what new applications does that bring to the forefront that simply can't be done today? Now, I've spoken to a few people on this, and that ranges from not much is going to change, which is a bit of a surprise, to yes, we can absolutely now do things that we never thought possible. It's hard to predict the future, but if you listen to some buzzwords about autonomous vessels, or even the ability to do things more autonomously, if you have that bandwidth coupled with that low latency, I would argue you will bring in new applications that simply we haven't seen today. I remember when 3G on your mobile phone first came along, and nobody figured out how to fill it with applications. And people scratched their heads and said, why do we need 3G? And then it didn't take long before the smart application-driven community saw an opportunity, and before you knew it, there were hundreds, if not thousands, of applications being developed for the mobile phone industry. And now we're into 5G, and they're already questioning when are we going to get the next and the next you know, if you build it, we will come, they will come. That is a true phrase that I believe strongly in. The time is now coming. I would like to think we move away from this thought that maritime is always operating 5 years behind what happens on the land. And in a few years to come, maritime will have the opportunity to be in parity, if not better, than what happens on the land at that point. Thank you very much for your attention.
Many thanks, Mr. Rapa. Actually, we have one question. But before this, many thanks for the presentation. I was among the majority of people here that never heard about you. But
That's why I'm here.
Yeah.
No, in all seriousness.
Not even in news.
Yeah.
I'm reading news, but I never came across you. But I found this very interesting, very promising project. And I think that if that project turns into reality, you have high chances of becoming a game changer in the market. I mean, I'm impressed. So we have two questions actually. First goes.
Joe,
Hey, Peter.
I agree with Tommy. It's very refreshing to see new technologies coming in, so we're excited about that. I got one clarification and one question. Your link speed, you said 15 gigabytes. You meant gigabits, maybe, right?
Yes, sorry.
Okay, sorry. Because it's 8 times and I don't want to. A second, Elon Musk is pretty, I'm going to ask you this question because I know you and I think you can handle it. Elon Musk is a pretty smart guy, right? He's not, he's done some pretty good stuff. Why didn't he do this? And can they convert to this? Can other LEOs convert to this technology with the existing constellation?
No, I mean, that's a good question. I think where we have the advantage is that we're not the first. We weren't the first. And I think when you were designing a network a few years ago, there were limitations, arguably, on what technology could enable you to do. And with laser technology today, in the last year, maybe a bit beyond, there has been significant advancements with companies that have been focused in building laser technologies. And they've done their testing and they've proven their technology. And because of that, I would say that's now finding its way into the design phase. There's no secret that Elon has now looked at optical laser satellite links. He didn't do it on day one because I just simply think that the technology back then at that design phase just wasn't ready enough to be able to adapt and pick that technology up. OneWeb are also talking about moving into that phase and looking at their next generation. So then you would say, well, why is that different than our network? We are still strongly of the opinion that with what we want to achieve, which is a B2B business model, not a consumer model, that not needing to use gateways is the right way forward. If I'm more consumer focused, yes, I can see the benefit of why you'd want to use a gateway, because quite simply then at that point you're breaking out into the internet and distributing your data from that point. That doesn't need to be overcomplicated in a consumer world. I think Elon, no, I don't know what Elon thinks. It changes. I would have said a few months ago, it's 100% consumer focused, 100%. So the slight move that we see into maritime has somewhat been a surprise. Will it continue? Who knows? Because at the end of the day, I think the revenue that you would look to extract from maritime versus in a true consumer model, the direct-to-home model, the how do I connect millions around the world model, revenue-wise is probably a lot more appealing.
Thanks.
Well, Joe, I think that Violaris knew what he was doing from the beginning. He left the best for last.
Oh, thank you very much. That's very kind.
Because you know what? After your 30-minute presentation, it reminded me of Star Trek. When years ago we said, no, that never existed. And now what you just said to us, I mean, it's like, really? Is it going to happen? Well, from now onwards, I will say, yeah, I know who Rivada is.
That's very kind. Thank you very much.
One question, cost-wise. Will you be the same as others in 2026, and will others follow? And what sort of hardware will be used on the ship or on land? Will there be any difference, and will it be cost-effective?
No, good, great question.
Thank you.
Always the challenging question, how much? I think the model, and I'm going to use Starlink again, just because they're published. And in today's environment, anybody else operating in that LEO fashion, OneWeb maybe, sorry, nobody really has rate cards. So what we see, at least with Starlink, is it's going to cost you $5,000 a month to operate an open, I was going to say all-you-can-eat plan with a variance of throughput. So we see that as a marker. That's too expensive. That's not merchant shipping. That is, I can see why the adopters are yachting and cruise right now, potentially ferry, where you have the people that can afford it, or you have a large number of people on one vessel that can help to offset that cost. But that's not the average I see in merchant shipping today. That's easily twice, I think, what the affordable budget, if not more, generally appears to be. Do I think it's going to come down? Absolutely. It has to, and it will. And that'll purely be based on the amount of data that will be put into the market by the likes of ourselves and other people. And I think it also comes down to usability and budget. If this is to become effective, then the pricing needs to be at a better level. I think the question was, will it ever get down to what you pay into the home today? No, but it will narrow. It will absolutely narrow. And like I think I started by saying, Euroconsult and NSSR have done a study, and their prediction on the per meg price is radically lower in the next few years ahead, and continuing to go down than it is being served today in this market. So absolutely, I fully expect we will be probably more competitive than what is seen in the market today. If I'm defending the point on price, I would say, even if it's the same, and I'm giving you an incredible amount of throughput with an incredibly low latency that's more highly secure, is it better at the same price? Absolutely. Absolutely. Will it be better? I believe it will. On the hardware side, we're still looking at the final design phase. So the things we need to conclude by the end of this year will be to select from a beauty competition the final satellite manufacturer, which we'll seek to do. The satellite design phase of the network needs to be bedded and locked by the end of this year. And then the launch partners, the launch partner and the launch slots that we need to select as well moving forward. What we're looking for on the hardware side is multiple options, multiple sizes. They will be smaller than what you see today. The clever thinking on new flat panel active phased antennas is that they will have the ability moving forward into the future to do multi-beam handling. So at one antenna at the same time we'll see several beams, which I assume is certainly going to help with handover, quick signaling, quick handover under the same position. Thank you very much.
Joe, hello. Can you hear me?
Yes, I can.
Okay. Joe, can you tell us where you guys stand in regards to licensing to operate it and delivering the service to various countries? Just
I'm going to take that in two ways. So licensing, in terms of spectrum, we have approval. We've got 4,000 megahertz of spectrum that we have approved. Licensing on the country is always a work in progress. You'll never get 100% of the countries in the world to put their hand up and say, you're approved. It just won't happen. What helps is, again, two things here. One is we're not looking at implementing gateways. So because of that, you don't need to have the license approval from a local regulator to go ahead and put your gateway into a certain country or location. So that helps us greatly on day one. There certainly will be countries that we will need to have the licensing approval from in order to downlink in the enterprise fashion, and potentially even maritime if you're downlinking into a corporate HQ or a reseller facility, so you can layer on your value adds before it goes out. So we've strengthened our regulatory team. We hired a wonderful lady a few months ago called Anne Vanderbroek. You can Google Anne. She's on LinkedIn. She is a very senior figure that for many years worked at Inmarsat on their senior regulatory team. And she moved from there after, I think, 15 or maybe 20 years. She moved to Avanti. So she's highly recognized in the industry. She's just brilliant. And so we have her, and she's on our team, and she's helping with our rollout phase, ensuring that we have the right regulatory licensing in the countries that we actually want to deliver this service to. And by that, I clarify there are certain countries in the world that we will not be doing business with.
Thank you. Just the last question, as we're running out of time now. Yeah, thanks.
Hello, thanks very much for the presentation. I would like, in continuation with my colleague here, to ask something. In 1930s, for example, nobody would expect that man would go on Earth, on the moon. So now we are close to the autonomous ships, unmanned ships. What are your considerations in the future for unmanned ships? Because there will be, of course, a decrease in the airtime communication with the crew. And do you expect to communicate with humanoids, or do you expect to be focused only with the data? Only data transfer in the future without communication with humans?
I know I'm good, but I don't know if I can answer the question on dealing with the non-humanoid race at this moment in time. I'll answer the one on autonomous vessels. Now you probably know better than me. Isn't there a vessel that was launched from Norway? Is it the Birkenhead? Yeah, and that is autonomous, probably sparing a few individuals on board to make sure it doesn't crash. I fully expect that's an area that absolutely in the future, whether we like it or not, will take hold. And you can argue maybe not for all vessels, but certain sub-verticals within the vertical of maritime can and should run things autonomously, absolutely. Do I see it's going to extend to land? Absolutely. Do I think there is no reason why after Starlink have their entire network in place, they couldn't do something clever with Tesla cars around the world? Because Silicon Valley is full of, well, that's maybe an exaggeration, not full. There are numerous tests going on with autonomous vehicles in the US today, Tesla being one of them. Elon Musk, Tesla cars. Elon Musk, satellites. It's not a stretch to say at some point in the future, things are going to either be done more autonomously, or arguably, they're just going to be used, the ability to use data better remotely will be increased. Whether that's from a positioning point of view to understand where vehicles are, vessels are, or from a how do I just simply upgrade my data better to that asset. and that will be done over satellites. I have no doubt. I have no doubt. Will they find human life on Mars? I'm not gonna, no, yeah. When he builds his, yes, community on Mars, then we may know. Thank you.
Can we get the next question for the panel? Yeah, thank you, thank you.